Hey mathematicians, this is Mrs. Shopper coming to you with the start of Unit 3. We're going to be solving equations. We're going to be utilizing the skills we've been talking about in the first few units about combining like terms, distributive property. We're going to be add up, and we're going to work to keep that equation balanced. And so this whole unit is going to be focused on that. So we're going to start today by looking at just what does it mean to solve equations? Why is it important? How do we ever use this, right? So let's just take this for you NASCAR fans out there. The average race car driver uses 125 gallons of gas during the Daytona 500. We want to know about how many laps will it take to use 60 gallons of gas if each lap is 2.5 miles. That's a lot of information we have to seek through. So when we're working through problems like this, we need to be able to solve equations, okay? So we'll come back to this later. So to start out with, we need to be able to take something from words and put it into numbers, all right? And again, that builds on the 4 forms of functions. We're looking at t-tables, graphs, verbal, algebraic. This morning, we're going to be working on going from verbal words to algebraic numbers and symbols, okay? That's what we're working on. This right here shows you, and it's in your packet as well, the different words that we can use for addition, subtraction, multiplication, and division. Use this as a guide. That's perfect. So let's take a look. There's one other one I want to add to here is equals. If you could add that to your note. Is and was the same as. If you want to add those down, that'll be helpful. And I know looking at the screen, it's not probably super clear to see what words are in those boxes, but that's why you have it on your notes, okay? So what we're going to do is we're going to go from words to algebraic. And when we do this, we're going to break it down really step by step across the way. So 6 would be 6. More than is addition. I don't know, I had a typo there. Twice a number. Twice a number means 2 times. So 2 times a number, I don't know the number, so I'm going to put an X or an N or an R or a T, whatever you want to put down, is 13. And when we go through that process of going from verbal to algebraic, go step by step by step. It's all right. Take your time. I'd rather have you do fewer problems and do them well than do a whole lot of them and get them wrong, right? Taking your time, making sure you're doing well. Let's try the next one, okay? So 50 is, that's equals the product of, product is multiplication. What are we multiplying? A number and 10. So 10 times a number. Going from words to algebraic, to symbols and letters. All right, now here, you've been kind of tuning me out, working on something else. Right back here, I need you to hear this. Excuse me, I need you to hear this. Less than. Okay, up here, I want you to write less than is a switch phrase. Now, what does that mean? Less than is a switch phrase. What that means is we're going to take what's in front of it and what's behind it, and we're going to switch it. Okay? We're going to take what's in front of it and what's behind it, and we're going to switch it. It's a switch phrase. So it's going to be a number less than is minus 16 is 14. When you see less than, that is a switch phrase. It is the exception to the rule. The rule is you just work left to right. The switch phrase tells you you have to flip it. It's the exception to the rule, okay? You're going to see it a few more times because we really want you to think through that. And I know you talked about it in 7th grade, but that was so long ago that it's good to bring it back and remind ourselves. Let's try this next one. The quotient. Quotient is division. What am I dividing? 3 times a number and 6. I'm dividing 3 times a number and 6. I could write it that way. I could take 3 times a number divided by 6. That would work, okay? A couple different ways. Let's try a few more and then you'll get some practice. This is taking on more like real life scenarios, not just words, but actually real life scenarios, excuse me. So Ashlyn's age is 6 more than twice Madeline's age. If the sum of their ages is 36, how old is each of them? Okay, so let's talk with this. Ashlyn's age, so let's use A. Ashlyn's age is 6 more than twice Madeline's age. And again, I'm going step by step by step. I don't see that switch phrase of less than, so I can work from left to right. So Ashlyn's age is 6 more than twice Madeline's age. Now, the second part of this is an equation to solve, which we haven't really gotten into, but it's good to at least introduce it to you. If we know that their ages are 36, so if we know that Ashlyn's age plus Madeline's age is 36, so I'm going to stretch you a little bit here. You've got it. I know that Ashlyn's age is equal to this. So I'm going to take 6 plus 2m, that's Ashlyn's age, plus Madeline's age to get 36. That is one strategy to use to solve this problem. Now, could you use guess and check? For sure. Could you do trial and error? For sure. Could you come up with a different strategy? Absolutely. All right. It's not my way is the only way. We got lots of different options with that. All right. So if we solve this equation out, I'm just going to solve it out. I know we haven't talked about this, so just hang in there with me. 3m plus 6 is 36. 3m is 30. Madeline is 10. And Ashlyn is 6 more than double that. She's 26. All right, the cost of a child's ticket is 4 more than that of an adult's ticket. So the cost of a child's ticket is equals 4 more than that of an adult's. That's my equation. This is the part I need you to get to right here. Right here. We'll do one more down here. This solving piece is setting us up for future work. So I'm just going to walk through how to solve it. Don't stress if you're not sure how to do it. We are going to hit this harder later on. Okay? If the cost of one child and one adult is 22, how much is each ticket? A child's ticket is 4 more than that of an adult, which now that I'm thinking about it, that seems really odd that a child's ticket would be more than an adult's. But hey, we're going to go with it. So we have that 2a plus 4 equals 22. Subtract 4. 2a is 18. And again, this whole equation solving part, if you're getting it, great. If you're not, we're going to spend a lot more time on it later on. Okay, it's just setting the stage up a little bit. So the adult is 9 and the child is 13. So odd, shopper, but it works. One more, and then I'm going to give you time to practice. Here we go. Zhang has a total of 92 coins in his collection. So 92 equals 8 more than 3 times the number of quarters in his collection. Okay, so that's our equation. 92 is 8 more than 3 times the number of quarters. So if I'm going to solve it, and again, this is what I need you to get to. Solving it, I'm okay if we're not there yet. It's setting you up so you can see what we're going to be getting into. So 84 is equal to 3Q. We're going to divide the number of quarters. It's 28. All right, it's time for you to work on your topic 1 worksheet. We'll see you next time. And I have to figure out how to stop the recording. Bye.